Assalamu alaikum class. I am Muhammad Hamad Ali from BS Chemistry 6th morning. The topic of my presentation is sputtering. First of all, we will discuss the key concepts that we discussed today in our lecture. First, factors affecting the sputtering, sputter deposition, primary and secondary knock-on, reasons for sputtering, requirements for sputtering, steps for sputtering, unique characteristics of the sputtering process, advantages and disadvantages of sputtering, applications of sputtering, sputtering deposition, film growth, and glow discharge sputtering. Sputter deposition. When an energetic particle strikes a surface, the target, a plume of material is released like the shower of sand when a golf ball lands in the bunker. Sputter deposition is a technique in which an energetic particle, like the ions of the noble gas, strikes on the surface of the target. Target material is that material from where the sputtering of the atoms takes place and deposit on the surface of the substrate. This effect is known as sputtering, and it is used to produce films of materials as thin as just a few millionths of a millimeter. This technique is used to deposit a very thin film of atoms on the surface of the substrate in order to prevent it from the environmental interactions. The source of the ions might either be a local plasma, diode or planar magnetron sputtering, or a separate ion beam source, ion beam deposition. There are various types of the sputtering that depends on the sources of the ions that strike on the surface of the target material. In this diagram, this is shown that when an noble gas is injected into the system, the electrons strike to the atoms of the noble gas and ejects the electron, and the ions are formed. These ions strike on the surface of the target material. When these ions strike on the surface of the target material, the atoms are sputtered off from the surface of the target material, and these atoms move toward the substrate or sample and deposit on its surface, and a thin film is formed. Now I am going to discuss factors affecting the sputtering. There are following factors that affect the sputtering: distance between target and substrate, energy of sputtered atoms, angle of incidence of sputtered gas, mass of sputtered material, distance between target and substrate. First we discuss distance between the target and the substrate. As we know that target material is that material from where the sputtering of the atoms takes place, and then these sputtered atoms are deposited on the surface of the substrate. The distance between the substrate and target greatly affect on the rate of sputtering. As the distance increases, the sputtered atoms take more time to reach the substrate, thus their energy greatly reduced due to their collision with their atoms. As the distance increases, the sputtered atoms from the surface of the target takes more time to reach on the surface of the substrate. Their energy decreases due to their collision with the atoms of the noble gas. Therefore, the sputtered atoms are unable to adhere on substrate surface. The sputtered atoms moves toward the target and deposit on it. The atoms that are ejected or sputtered off from the surface of the target materials when they have to cover a large distance, their energy decreases and they come back and adhere on the surface of the target and does not deposit on the surface of the substrate, and the coating does not take place. Next, energy of sputtered atoms. As the energy of the sputtered atoms decreases, the process of re-sputtering starts and sputtered atoms unable to deposit on substrate surface. As we know that as the sputtered atoms energy decreases, the sputtered atoms become unable to deposit on the surface of the substrate. Therefore, the sputter deposition does not take place. In this way, the energy of sputtered atoms affect the process of sputtering. So, energy of sputtered atoms directly relates to the rate of deposition. The other factor that affects the rate of sputtering is mass of sputtered atoms. As the mass of the sputtered atoms increases, their speeds slow down and their energy decreases continuously. Due to decrease in energy, the process of re-sputtering starts. As we know that when the mass of the atoms increases, their speeds decreases, and due to their decrease in speed, these atoms are unable to reach on the surface of the substrate, and therefore the rate of sputtering decreases. Primary and secondary knock-on. When argon ion strike to the target, first atom ejected from the target, reflected, and then again strike to the target atom sputter from the surface. When argon ion strike on the atom on the surface of the target material, these atoms ejected and reflected in a spherical way that an atom from the surface of the target material ejected, and this is known as primary knock-on. The sputtering of atom from target material during this reflection process is called primary knock-on. When second atom gain energy from the incoming argon ion and the adjacent atom also sputter even due to low energy. This is called low energy or secondary knock-on. When an argon ion strikes on an atom, the neighboring atom gains energy and sputter off. But this is low energy and this atom is unable to deposit on the surface of the substrate. During the primary knock-on, the energy is high, but during the secondary knock-on, the energy is low. What are the reasons for sputtering? Use large area targets which gives uniform thickness over the wafer. Wafer is the substrate or the material on which the coating takes place. Sputtering is used for coating. Control the thickness by deposition time and other parameters. Even material with very high melting points are easily sputtered. Sputtered films typically have a better adhesion on the substrate. Sputtering can be performed top-down. This is explained by the diagram. A solid or a liquid as a source is used. By the process of evaporation, gas phase is created and this is transported to the surface of a substrate where it is deposited. This is a type of physical coating technique. In the next diagram, the inert gas is injected in the sample and the electrons are moved from cathode to anode. When these electrons strike with the noble gas atoms, eject the electrons, and the noble gas ions are formed. These ions strike on the surface of the target material and eject the atoms. These atoms travel toward the substrate where they deposit to form a thin film. What are the requirements for the sputtering? Vacuum, inert gas, power supply, and sputtering gas. Steps for sputtering. The first step is ions are generated and directed at a target. As I have already told you that the ions are created due to the movement of the electrons. These electrons strike to the atoms of the noble gas and the ions are generated. The ions sputter target atoms. These ions strike on the surface of the target and ejects the atoms. The ejected atoms are transported to the substrate. Atoms condense and form a thin film. These atoms that are ejected from the surface of the target travel toward the substrate. On the surface of the substrate, these atoms deposit and form a thin film. Unique characteristics of sputtering. It is a uniform thickness over large surface area. Simple thickness control. The alloy composition maintains stoichiometry with the original target composition. The composition of the target is maintained on the surface of the substrate. Deposition rates do not differ a great deal from one material to another material. Sputtering cleaning prior to initiating film deposition. Sputtering process is also used for the cleaning purposes. For example, in order to remove the corrosion from the surface of the solid material, the ions are bombarded on the surface and that ejects the damaged atoms, and therefore sputtering is helpful for cleaning purposes. The lifetime of a sputtering target may be as long as hundreds of runs and is seldom less than 20. Advantages of sputtering: able to deposit a wide variety of metals, insulators, alloys, and composites. Replication of target composition in the deposited films. Capable of in cleaning prior to film deposition by reversing the potential of electrodes. There are two electrodes that are used, one is anode and other is cathode. The target material is present at cathode and the material on which the deposition takes place is present at anode. By reversing the potential, the cleaning of the atoms that are damaged on the surface of the substrate by bombardment of the noble gas ions. better film quality and step coverage than evaporation, can use large area targets for uniform thickness over large substrates, sufficient target material for many depositions, no X-ray damage, simple wide choice of coating material, easy to obtain stoichiometric alloys and compounds coatings better than evaporation, low substrate temperature, excellent uniformity over complex and large areas. Sputtering is a better technique from uniform thin coating. Disadvantages of sputtering: substrate damage due to ion bombardment or UV generated by plasma. As we know that plasma is produced that consists of electrons, atoms of noble gas, ions of noble gas, and the photons. These generate ultraviolet radiations, okay, or ion bombardment on the surface of the substrate damage it. High pressure 1 to 100 millitorr 10 to raise power -5 in evaporation. High pressure is used in sputtering, while low pressure is used in physical vapor deposition. Deposition rate of some materials is quite slow. Most of the energy incident on the target becomes heat, which must be removed. Difficult to deposit in uniform layers of complex shapes such as turbines blades. In simple shapes, sputtering deposits a uniform thin layer, but in complex shapes, it does not deposit a uniform layer. High performance thick coatings are hard to produce due to high internal residual stress, relatively low kinetic energy of the atoms. Deep recesses are usually about 1 nanometer. Applications of sputtering: thin film deposition. The major function of sputtering is to deposit a very thin film. Microelectronics. In microelectronics, various semiconductors are used and these semiconductors are deposited by thin films. Decorative coatings, protective coatings, etching of targets, microelectronics, patterning, CMOS complementary metal oxide semiconductor, NMOS N-type metal oxide semiconductor, PMOS P-type metal oxide semiconductor fabrication, surface treatment hardening. For the treatment of the surface, sputtering is a better technique that prevents from harmful effects of the environment. Microelectronics, CPU processors, cell phones, iPod, watches, batteries. In all these microelectronics, thin films are deposited to prevent it. Solar panels are aerospace and defense, heads-up cockpit displays, jet turbine engines, mirrors for optical and X-ray telescopes, night vision equipment. Wear coatings, anti-corrosion coatings, anti-seize coatings, dyes and molds, sewing needles, tool and drill bit hardening. The conclusion of the applications is that the sputtering is a technique that is used to deposit a thin films on the surfaces of the substrates, electronics, solar panels, aerospace, and the major function of the sputtering is also to prevent from the surface of the substrate from the chemical reactions with the environment. For example, sputtering protects the corrosion. Anti-reflective coatings are anti-glare coating on cars, jewelry, mirrors, night vision goggles, oxidation resistance on cutting tools, chemical factories, medical drug delivery, automotive, auto headlights and tail lights, auto trim components, drivetrain bearings and components, wheels and rims. Optics, anti-reflective, anti-glare coatings, cable communications, laser lenses, optical filters for achromatic lenses, spectroscopy. Applications of sputtering targets. A metallic film is also deposited on the surface of glass in order to save the heat. When a specific metallic film is deposited on the surface of glass, the solar energy that enters indoor is only 40% and the reflection is 60%. And the thermal reflection and thermal convection is about 80% and radiations that emitted out from indoor is only 20%. In this way, the special metallic films on the surface of the glass prevents the heat exchange. Applications of thin film technology, microelectronics, CPU processors, cell phones, iPods, watches, batteries, solar panels, anti-reflective coatings on cars, jewelry, mirrors, night vision goggles, oxidation resistance on cutting tools, chemical factories, drug delivery. All these techniques uses sputtering as a major deposition technique to prevent it from environment to coat it and for decorative purposes. Application of sputtering targets. The phenomena of sputtering is employed in the semiconductor industry for depositing thin films of different constituents on silicon wafers. Silicon wafer is a semiconductor that is used in microelectronics devices, and this silicon wafers is deposited by a thin films. The process is also employed in optical application by depositing a thin film on glass. The process of sputtering occurs at extremely low temperature, due to which it is the perfect method for depositing thin films of different constituents as compared to physical vapor deposition technique by evaporation, where high temperature is used, and this is better technique because here low temperature is used. Another use of the sputtering process is the corrosion of white material. The application of the sputtering process is the most important one and commonly used. This is a process widely used in the formation of thin films on material, engraving techniques, erosion of white material, and analytical techniques. Sputtering deposition film growth. Sputtered atoms have velocities of 36 e5 centimeter per second deposition rate and energy of 10 to 40 electron volt. The energy of the sputtered atoms that sputtered off from the surface of the target materials have the energy that is between 10 to 40 electron volt. Many of these atoms deposited upon the substrate. Thus, sputtered atoms will suffer one or more collision with the sputtered gas. When these atoms move from the target to the substrate, these atoms collide with the noble gas ions and atoms, and therefore their energy decreases. The sputtered atoms have arrived at surface with reduced energy. When the atoms from the target moves toward the substrate, due to large number of collisions, in their pathway, the energy decreases and the sputter atoms arrive at the substrate surface with only 1 to 2 electron volt energy. B back scatter to target. These atoms can move back and adhere to the target. The sputtering gas pressure can impact on film deposition parameters such as deposition rate and composition of the film. In this sputtering, argon is ionized by a strong potential difference and these ions are accelerated to a target. After impact, target atoms are released and travel to substrate where they form layer of atom in the thin film. Sputtered gas pressure. The sputtering gas pressure can impact on film deposition parameters such as deposition rate, composition of the film. Next, one type of sputtering is glow discharge. Sputtering means the energetic particle used to strike the target is generated by glow discharge. Creation of glow discharge: tube filled with argon, neutral, no charged particle between cathode and anode. Elastic collision, no energy exchange. In elastic collision, energy not enough high excite electrons emitting photons. Energy high enough ionize electrons cause secondary free electrons. When the noble gas atoms are when the noble gas atoms are injected in the system, as we know that due to the potential difference between cathode and anode, the electrons moved from cathode to anode and these electrons are known as primary electrons. These electrons when strike with the noble gas atoms, they form noble gas ions and the secondary electrons. These secondary electrons and the primary electrons are accelerated toward the anode. These all are known as collectively plasma. Both free electrons are accelerated again so cause cascading or gas breakdown. Flow of electron is collected by anode. Current will quickly decay to zero. All the primary and the secondary electron moves toward the anode and the current will decay to zero. Some are the kinds of glow discharge sputtering: direct current radio frequency diode sputtering, triode sputtering, magnetron sputtering. Direct current sputtering. Target is held at high voltage. Substrate may be at positive ground or floating potential. It means that substrate is at anode and target is at cathode. Argon gas is introduced at a high pressure less than equal to 10 Pascal. When argon gas is introduced, due to the movement of the electrons from cathode to anode, these electrons strike with the argon gas atoms, eject the electrons, and argon ions are formed. These ions strike on the surface of target and atoms are sputtered off, and these atoms strike to the surface of the substrate and deposit on it. High voltage 100 to 3000 is applied between anode and cathode. Visible glow is observed when current flow between cathode and anode. This visible glow is due to plasma. These regions are a result of plasma, a mixture of electrons, ions, neutrons, and photons. Density of particle depend upon gas pressure. Comments: simple, relative ease in fabrication and thickness, uniformity over large area. The sputtering technique is used for uniform thickness and fabrication, relatively high deposition pressure and relatively high substrate temperature. In DC sputtering, the temperature is relatively high and pressure of the deposition is also relatively high. This is all about sputtering. This diagram explains DC plasma sputtering. As it is shown in the diagram that substrate is at anode, that is at high potential, to be coated in cathode material, and target is placed at cathode from which the sputtering of the atoms takes place. When the ions of the noble gas strike on the surface of the target, the atoms are sputtered off, and these atoms strike to the surface of the substrate, where these atoms deposit and form a thin film. This is all about sputtering, advantages, factors affecting the sputtering, disadvantages, applications of the sputtering, and plasma glow discharge sputtering and direct current sputtering. Thank you very much.